likely to be replaced. Okay, so that's how it all kind of works. Next up, I'm going to tell you just how easy it is to cause a free buffer wait. So I got a little video I did of this when I actually did this, and I want to show you this right now. So let's roll the video. So my objective here is to place on the system a free buffer wait load and also take a baseline of the timing situation and also the workload situation. So the first thing I want to do is to place that free buffer wait load on the system. And to do that, I'm going to first run a query right here, a real simple query. Okay. In fact, I'm going to do 3 of these. Okay. And then I'm going to actually look at my real-time session sampler, it's called. This is part of my OSM toolkit. You can download that for free off my website. And so I'm going to look at every Oracle SID and every Oracle serial number. And I want to report on a session even if it's consuming CPU or waiting. And if it's waiting, I don't care what the wait event is, and I want to take a snapshot of $8 session every 3 seconds. Now the output is going to go to this text file right here. Okay, so I'm going to press return to start sampling, and here I've already did the tail-f on the file, and you can see right now that we have our sessions that are consuming CPU, and there's also some wait time right here. So you'll see that there is some physical I/O taking place. Okay. You can see the sessions sometimes are waiting, sometimes they're consuming CPU, but there's no free buffer waits. There's no free buffer waits. Right? And the reason is I have not introduced any DML. I have not caused a shortage of free buffers. So what I'm going to do is I am now going to introduce some DML. Okay, so to do that, I'm going to run a different query right now. If it's not a query, I'm going to add one DML statement, and you will see very quickly you're going to start seeing free buffer waits. There you go. We see the DB file async IO submit. That's coming from the database writer, and then there's also some log file parallel writes. That's coming from the log writer. So the key point here is that the introduction of the DML triggered the free buffer waits. Now, in order to compare what's going on the system with kind of our baseline, when we actually make some changes later, we need to get an idea of the timing situation and the workload situation. Okay, so to get the timing situation, I'm going to run this real simple script from my OSM toolkit, which is going to give me timing information. Okay, and this takes a while because the system is just getting hammered right now. This is going to give me some timing information when I run it again. And also what's going to take place now is I'm actually going to take a baseline of the workload. And so I'm going to kick off some PL SQL right now. Okay. So essentially what that's going to do is it's going to give me a 60-second snapshot of the DB block changes and the session logical reads, because really those are the 2 good ways to measure the throughput or the workload on the system. Okay. So while that's taking place, let's take a look at the IO subsystem. What I did, I've run a real simple IO stat command. You see, it's that IO. I ran that IO stat-xt 10-second samples, and basically do it forever. And you can see that right now the IO subsystem is just getting hammered. It's practically 100%. Now that's going to be important in a little while, because one of the solutions to free buffer waits is to add more database writers. And I'll tell you about that a little bit later. But the IO subsystem is already just getting hammered by write activity. You can see that right here. So if I add more database writers, that could even make a bad situation even worse. All right, so there's our baseline for the block changes and the logical IOs. Okay, now I want to get the timing situation as well. And so our timing situation was actually about 1.5 minutes or 103 seconds. And we can see the top wait event is the DB file async IO submit. That's coming from the database writer. Oracle's having problems timing that currently. So that could be idle, could be not idle, or a combination actually. And the next wait event is our free buffer waits. And that is what we're going to focus on, trying to reduce that percentage with some various solutions. So this was one way to cause a free buffer wait. I had some physical reads taking place, and then I introduced some DML, and that triggered the free buffer waits. I hope you enjoyed that video. I think it's really interesting to see how we caused a free buffer wait, because if we understand how something occurs, what it takes to cause the problem, then we can use that information to kind of undo the problem, and those turn out to be very effective solutions. And we're going to use that to our advantage coming up later in the seminar. But I want to focus